Hello everyone, so this is Mohammed from PYCAD and this is a new video in our channel. So I wanted to show you how you can use PYCAD library to prepare your dataset to train a YOLOv8 model for medical image segmentation. But before that, I just wanted to give you like a quick review about what is the new release that we have just released for the PyCAD library. So I will just like go over like 2-3 new features that may be useful and helpful for your project. So yeah, let's get started with that, and then we can go to our main focus of this video. So if you see here, this is the repository of our library. So I added like new thing here in the README. So instead of putting all the new features in the README, I just wanted to put them in the different file. So in each time there is a new features, you can just check them in a file called release features. So like the new features of release. So in each time we have a new release, like all the new features will be here. Okay. So for this new release, which is 0.0.9, we added a few things. So let me just go over the things just briefly. I will not take a lot of time talking about this. Then we go to the tutorial. Okay. So the first thing that we added here, like we had a problem with the data splitter. We were using a code based on scikit-learn, but this code was having some issues in the sorting. So we were not having the same like the corresponding labels for the images, especially when we tried using this in Google Colab. So we implemented our custom data splitter, which is based on pure Python. So it is very useful, and we tested it, and we also added a unit test for this. So we will be adding unit tests for each module that we will have. So for now, we started with the data splitter. So there is a unit test that you can use. We are using it before the release, but you can also use it whenever you use one of the modules. So for example, if you use the data splitter, because for now we have unit tests only for this, we will add the others soon. So if you use data splitter and you maybe you are not sure if the split has been done correctly or not, then you can use the unit test to test if the files has been split correctly or not. Okay. And then we added two things. We added the DICOM slider and the Nifty slider. So what are these? So if you have like a volume of 3D files. So for example, you have multiple 2D files, which are the DICOMs, or you have one 3D representation, which is a Nifty file. And then you want to do visualization like slice by slice. Like I'm not talking about a sophisticated software, just a Python code that can plot a pop up a matplotlib window, and you can visualize each slice dependently. So you can use like the DICOM slider or Nifty slider. Those are new in the release. You can find them in the visualization module. So here in the visualization module, you will find we have the okay, for the visualization we have sorry, this is documentation. So in PyCAD we have visualization module, we have the Nifty visualizer, and we have the DICOM slider and the Nifty slider, because the Nifty visualizer is a 3D visualization using video. But if you want to do visualization like slice by slice, then you can use the DICOM slider or the Nifty slider, and like the example is here. So you can just see the example and try it yourself. You will see that it is very useful, especially if you use, for example, PyCAD to generate or to convert new files, and then you want to visualize them directly in the code, then you can use this. Okay, now we can go to the purpose of our code, of our video, sorry. So the idea here is to do the mandible segmentation from the panoramic X-rays. So this is a tutorial that has been added to the repository. So if you go to tutorials, there is a notebook here, okay, called PyCAD YOLOv8. So this notebook is the main purpose of this video. And also I wanted to mention something that it was in the last release, but we didn't do any videos about this. We will have future videos about that, but since it is like there is a feature that has been released before this release, and it will be used for this tutorial. For this reason, I need to talk about it, which is downloading the dataset. So we have added the new feature to our library, which is how to download one of over 120 different data sets. Most of them are CT scans. So you will find that we have multiple data sets that are ready to be used and downloaded directly in your server, your system, because sometimes you need to download the dataset from like using the UI or Google Chrome, then you do download from the website and use them. And also whenever you want to download, most of the time you need to download the whole dataset. Maybe you don't have space, maybe you want to experiment only with few cases. So in this case, what we did, we created like a dataset module that can help you download just what you need. So we have like subgroups, we have defined subgroups, but let me just show you one example so that you can get an idea. So we have in the PYCAD, then data sets, then for example, for now we have some segmentation data sets. So we have the total segmentator data set. I don't know if you have already heard about it. So maybe you do know the model total segmentator, but here I am talking about the data sets that has been used to train that model. And we have some of the Decathlon data sets, and we have diverse here. For now, there is only one data set, which is the data set that will be used for this tutorial. And for the others here, we have, you see, we have multiple data sets that are available now. So all of them, like they are over 120, I think they are 126 or 127 different data sets. And as I said, most of them are CT scan. Maybe there are 2 or 3 MRIs, and there is 1 2D data set that will be used in the tutorial. So here, if you want to see, like we have different ways to download. Most of the time we have subgroups. You can download 100 cases, 200 cases, 400 cases, or all depends to the dataset. So for example, this one contains 1,225 datasets. So if you download all the datasets, and you see the examples are here. So if you download all the datasets, which means that you will download the whole 1,225 cases. But if you want to experiment only with 100, then you can download 100, etc., etc. And the idea behind this is that it will help you to download the case, to download the datasets anywhere you want, and it will be very structured. You will have only one folder called dataset, then the name of the dataset. Then you will have 2 folders, one volumes, one segmentations, which is very clean, very easy to use. And of course, you can add more things to that dataset, but like whenever you have 2 folders, one volume, one segmentation, you are already in this simple point to start your project in medical imaging. Okay, so this is the idea that I wanted to share before going to the tutorial. Now let's go to the tutorial here. So the idea here, as I said, we will use a data set. Let me just show you diverse. So this is the data set that we will use. It is called like Mandible Panoramic X-Ray. So it is for the segmentation. Let me just go to the exact, or to the source of the data set to show you. Yeah, so here is the link to the source where we got the dataset, but now you don't need to download. As you can see, you don't need to download it here. And even if you download it from here, you will find different folders and the dataset is not structured. But here, if you download it from PYCAD, we have already structured it and clean it, so that will be easier for you. And I will show you step by step the tutorial, how you can do everything here with ease, okay? So to open the open the notebook, there are multiple ways. You can either download it or clone the repository or anything you want, or you can, for example, use Google Colab, which is the idea of this video. So I will use Google Colab to make it easy for you. So here I will go to Google Colab, okay? And I will try to open the notebook. There are also 2 ways of opening it, either to download the file from the tutorials here and then upload it, or you directly access it through GitHub here from Google Colab, okay? So let's do the easiest way, which is like we don't need to download it. We just need to go here to GitHub. You need to choose my GitHub repository. Otherwise, like if you have forked the project in your profile, for example, then you can select it from your profile, no issue. But if you are just following my tutorial, then you can take it directly from my profile here. So Amin0110, okay, so this is the username, and then you need to find the repository that contains the tutorial, which is the repository of the library, which is PyCAD. So here is the repository. So we have Amin0110/PyCAD, okay. Let's select it, and since I have only one notebook in my repository for now, because the other tutorials are like Python scripts, and here it search for the Jupyter notebooks. So this is the notebook that we have, which is PyCAD YOLOv8. So let's just click on it to be opened. Let's wait just a few seconds. Okay, so now we have the project opened. As you can see, it is already structured and ready to be used. And as I want to say here, we will not write the code step by step, but I will just explain how it works, and you can try it yourself because it's very easy and very documented here. Okay, and for example, most of the steps that we use to prepare the data are from PyCAD, and each step of them has already documentation that you can already read here if you want. Okay, so let me just start by the installation. And before that, you need to install, you need to initialize your notebook. For me, for example, I have already the Pro Plus plan, but don't worry about that to run YOLO model with this dataset, because dataset, it contains only 116 images, which are cases, let's say. So you don't need like very powerful GPU, like even in small PC, you can run this model. But yeah, don't worry about the Pro Plus. Even if you have like the free plan, everything should work with no issue. Okay, so let me start by the installation, as I said. So let's start by installing the how do we call it? Let's start by installing the library, which is PyCAD Medic, because the library is called PyCAD, but to install it using pip, you need to use PyCAD Medic, because like PyCAD directly does not work since it is already taken. Okay, so you need to do pip install then PyCAD Medic. Since I have already tested that, I think that it should be installed already, but let me try. Import PyCAD, run anyway. Yeah, since I have already tested the notebook here, so it is already installed, but for you, you need to do like this. Let me just add a new cell here. Okay, so you just need to run this, which is pip install, then the PyCAD Medic, and it will be installed, because also PyCAD Medic depends to other libraries that will be installed directly with it, so don't worry about that. You just need to install this, and you need also to check whether you have the exact or the correct version. So you need to have like version of 0.0.9 or greater. Okay, so we have PyCAD dot version. Okay, so let me run this to check the version. So it is 0.0.9, which is the latest one. So I don't know when you will see this video, but you should at least have 0.0.9 or greater, because less than that, you will have some issues. For example, with the data splitter, it will not work properly. You will find, because in like older versions, I was using the scikit-learn code, which is not working correctly in Google Colab. Okay, in Windows it works with no issue, but in Google Colab it is not working. So you should preferably use 0.0.9 or greater than that. Okay, so after doing the installation, you need to install also the Ultralytics, which is the library behind YOLOv8. So you need also to install this using pip install Ultralytics. Preferably you can use this version, because I have already used it and test on it. But if you don't want to use it specifically, no issue. Okay, so you just need to install the Ultralytics. Okay, so after doing the installation, let's start with the most important thing, which is to download the dataset. Okay, so to download the dataset, I think here I have it already, because as I said, I have already tested it. But to download the dataset, you need to import the Mandible dataset, which is the Panoramic Mandible X-Ray dataset. So you need to import the module, and then you need to download it. And as I said, since we have only 116 cases, then I didn't want to split them into subgroups, because it doesn't have any sense. So we have just to download everything, which is all here. So the keyword all means that we will download the whole dataset. Okay, so as you can see, if I go here, dataset, and this is the folder or the folder name of the dataset, which is X-ray panoramic mandible. And whenever the download will happen, so the zip file will be deleted, so no issue, don't worry about that. You will have very clean workflow, which is dataset, then the name of the dataset, which is X-ray panoramic mandible. Then you will have two folders, the images, and you will have the masks. Okay, so the TXT and YOLO, these ones you will not have them at the beginning because these will be created during the tutorial. Okay, sorry about that. I didn't expect that I will see everything here in the Google Colab ready, but I just wanted to explain that so that you will see why I have them already from the beginning. But don't worry about that. For you, we'll have only images and masks, but these will be created during the video. Okay, so whenever you do the download, you will have image masks. Now we need to create the polygons, because to train a YOLOv8 model, you cannot use the masks or the binary masks, but you will need or will require the polygons that represents the masks. Okay, so to create the polygons, we can use directly PyCAD. I have already a module that can help you do that. So PNG to TXT converter and MC, which is multi-class. So even if you have multi-class masks, then don't worry about that, it will be taken in consideration. And here you can see the example if you want. So for each module there is small explanation and there is an example of usage, so don't worry about that. Anything here we are doing for PyCAD, we are adding documentation, so that will be easy for you to use. Okay, so whenever you import it, you need to define the folder to the mask and the folder to the output, and then the output, which is to save the TXT. So the folders here are already structured, and if you are using the same tutorial, so you don't even need to change them, because they are pointing to the exact location for everyone. So whenever you download this folder will be created, also this folder, this folder, this folder. So the archi is the same, and here we have content, which is for the Google Colab. So if you are using Google Colab, you don't even need to touch these spots, but if you want to play with them, of course, you can always change these files. Okay, so here we are reading the masks and saving the TXT. And whenever you run this folder TXT will be created, and you will have these TXT files, and each TXT file contain the class plus the coordinates of the polygon. Okay, and then after completing after creating the TXT, you will not require but recommended to have the split for the train and validation and test if you want. I will not do the test because we have only 116 cases, so let's just use them for training and validation. But if you want to do testing, you can do it also. So to do the split, you can use the data splitter from PyCAD also. So this will help you to do the splitting. And as you can see, we have the train ratio, validation ratio, and the testing ratio. Okay. So if you don't want to use like any test cases, so you just need to put it as 0, like 0%. So like the probability will, for example, we'll do for the training 0.8, which is 80%, and 20% for the validation, and 0 for testing. And you can play with this if you want. And if you want to delete the inputs after doing the splits, you can activate this flag also. Okay. And when you run this, you will have the generated files here. As you can see, we have the folder YOLO because we used it as the output folder. So the output folder here, YOLO, will contain the test, which is like empty folder. So it is just something that we don't need. And the training here, you will see that we have the images and the labels. Plus for the validation also, we have the training and the images and the labels, which are the TXT files. Okay. And then to train the YOLO model, you will require a dataset.yaml file, which is this one, that shows where is the path to the train, what is the path to the validation, and the number of classes and the names of the classes. Okay. And to do that, you can either do it manually, but if you are doing this process multiple times, preferably you should have just one function that do that. And in PyCAD we got you, so you have already PyCAD.dataset, import the YOLO dataset YAML that will take the paths and generate the folder for you. And it will be placed directly here in the folder YOLO. So everything here, like all the paths are structured and can be used directly without any editing. But as I said, if you edit something somewhere here, for example. So this will affect the other parts. So don't like if you change something here, so be careful to be to change these also, because sometimes it won't work because it's searching for a file in some specific direction or directory. Then you need to update it also here. Okay, so now whenever we run this cell, we will have this file created, and whenever we have this file created, we can start the training. So the training, like here we are outside PyCAD, because everything here is related to PyCAD, from how to download the dataset, to create the polygons, do the splits, create the dataset.yaml. But from here, we are just doing the training or validation. Okay, so I have already added these, so I didn't want to just show you how to prepare a dataset, but I added the whole example. So this example is directly from Ultralytics. So you can, for this example, I am using YOLO small architecture. So I used it and I trained the model for 100 epochs just to test. So I don't have the outputs here, but the model was about 87, like I think 87 or 85% for the validation accuracy, mean average precision, not accuracy, sorry. So like it is not bad, but as you remember, we are using 116 data sets, so which is like very, very small data set. But yeah, this is just for testing and to show you where we can place PyCAD in our project. So yeah, this is the idea about the training. And whenever you have the model, so if you don't want to train the model, you want directly to use one pre-trained model, so you can download it from here. But if you want to train a model, then you can use this and the model will be trained. And then you can use this section here to do the prediction. So this section is just like a Python code to do the prediction. So YOLO, and then you give the path to the model to initialize the model, and then you do the prediction. And here we are doing the prediction, and we are extracting the mask and the bounding box. And then here, like just OpenCV part to take the mask and to change the color, for example, decrease the opacity and overlay it on the image. Also, we need to do the resize, which is being done here, and then we are showing the image. So if you are using Google Colab, then please consider using CV2 imshow. But if you are using if you are running the code in your local machine, then please consider using cv2.imshow. Okay, so yeah, this is the example that I wanted to show, and this model can be used anywhere if you want to download it directly here and use it. And the same code here can be converted into script and using this for your projects, your examples. And I hope that this was helpful, and the purpose was also to show you how to place PyCAD to your projects. And yeah, I will try to do more examples and more videos on 3D scans in next videos to show you more and more the features, because we have other features that are hidden. Maybe no one knows about them, and we are trying to develop more features to make your projects easy. But yeah, like we'll try to update you by videos, blog posts, so you can follow us in our blog posts on like on YouTube. You can follow us on our website, on LinkedIn, Instagram, like we are everywhere, so you can always do that. And if you are trying to do any project in medical imaging, you can also contact us at contact@pycad.co, so we can try to help you with your project. So we are doing consulting also in medical imaging, so we can create a custom project for you, or segmentation model, classification model, or any type of medical imaging projects. You can always book a call with us, and we can try to see how we can help you, how you can help us. And yeah, let's collaborate. And yeah, see you in next videos. Bye bye.